I'm Anil Kumar. Welcome to my series on trigonometry. We are discussing transformation of functions and their graph. In this video, we are going to consider the cosine function. So, sine function is the parent function, which when translated by 90 degrees or pi by 2, we get cosine function. So in this video, our focus will be on understanding the characteristics of cosine functions, how are cosine and sine functions related. We'll look into transformation of cosine functions, graph of cosine functions, write equation from the graph, consider domain and range of a cycle of a cosine function, and practice with some examination style questions. As you have earlier also seen while discussing the sine functions, that a function could be written as a cos k x minus p plus q. That is the general form of a cosine function. Now, in this general form, that capital A gives you the amplitude, which is also the vertical stretch or compression as compared with the graph of cosine x. The value of k represents the horizontal stretch or compression. It provides you with the period of the graph also. K is related with period as 360 degrees divided by the value of period. If you're working in radians, in that case, it'd be 2 pi divided by the period p. Lowercase p is the phase shift, right? It is horizontal translation or also phase shift. Q is the vertical translation. The graph shown here is vertical transformations of the cosine function. Now let's look into the characteristics of cosine functions. When we talk about cosine function, we are looking for a graph which starts with the maximum, right? So it starts with the maximum. Important thing, it starts with maximum. So when I say starts at, that means the coordinate point is at 0 degrees, cos of x is 1. Okay? That is where it is. And then it goes to 0, -1, 0, and 1. And that gives you one cycle. So this is your one cycle from 0 to 360 degrees. So most of the time we'll be discussing transformation within this cycle, right? What happens to the 5 key points which have been highlighted here when the function gets transformed, right? That is what it is. So let me just highlight the 5 key points that you're talking about are these key points, right? Starting with the maximum 1, 0, -1 the minimum, 0 and maximum 1 for the cosine function. Domain for the cosine function is all real numbers. As far as range is concerned, you can see it is between plus and -1. We also write absolute value of y is less than or equal to 1. The period, as highlighted here, is 360 degrees or 2 pi radians. It has even symmetry. Just try to understand this term, even symmetry. Even symmetry really means that cos of minus x is equal to cos x. On the graph, you will find that this is symmetric about the y-axis. Symmetric means that we have points on either side of the y-axis which are same distance away as shown here, right? So that is what is even symmetric. You also see that the graph is concave down for the positive values. So these are the positive values and the graph here is concave down, correct? And it is concave up for the negative values. That means that we have a maximum value here, since it is concave down, that turning point, and a minimum value in the position where it is concave up, right? So this is your concave up portion where the values are negative. Is that clear to you? So that is your concave up, which leads to the absolute minimum value for a cosine function. So as I was saying, we have a maximum value of 1 at x equals to all the multiples of 180, 2n times 180, right? So 0, 360, 720, and so on. And it has a minimum value of minus 1 at odd multiples of 180 degrees. Zeros. These are the zeros where the y value is 0. These zeros are at odd multiples of 90 degrees. And the key points, I've already discussed these 5 key points. Well, if you want to convert to degrees to radians, we know 360 degrees is 2 pi radians, 180 degrees is pi radians, and 90 degrees is pi by 2. Now, let us consider how are sine and cosine functions related. We basically call them sinusoidal functions. So sine wave is considered to be the parent function. Cosine is translated sine wave by quarter of a cycle. Now we will see how, right? Now, cosine leads sine by quarter of a cycle. So if you see, the cosine function starts with the maximum, right? But the maximum for sine comes later. So that means cos leads, right? This is what we mean by saying that cosine leads the sine by quarter of the cycle. Perfect. One full cycle here is from 0 to 360, right? That is the half of the cycle, and this is quarter of the cycle, correct? So that is the quarter of the cycle. You get the idea, right? Quarter cycle. So the blue graph here is the cosine function, and the red graph here is the sine function. Is that clear to you? So cosine leads, it comes before sine whenever you sketch a graph. Maximum for the cosine comes quarter of a cycle before the maximum of the sine function. Cosine graph is obtained from the graph of sine by translating it quarter of the cycle to the left, and therefore we could write the relation as cos x equals to sine x plus pi by 2. You get the idea. So that is shown here, that sine function when shifted left by pi by 2 gives rise to cosine function. Talking in radians, it is pi by 2, right? In degrees, 90 degrees. So that is how you could actually figure out which is cosine, which is sine. Cosine leads the sine function. Now, based on this, here is students' activity. I would like you to pause the video, read the question, and answer. The question here is, the graph of sine and cosine functions are given on the same axis, as shown here, right? Find the period of the sinusoidal function, identify them as sine as cosine functions, explain how the sine function graph can be obtained from the cosine function graph. So you can pause the video, answer this particular question, correct? As we had just learned, we're looking for the maximum, right? So this maximum for cosine happens to be at 0, and therefore this is your cos function, correct? And the green function shown here is the sine function. Well, the time period is different. So let me just write cos and sine, all right? We'll figure out the time period also. And we see that is the reason, because the cosine function leads, correct? That is the whole idea. So that is how we actually can figure out which one is sine and which one is cosine. The question here is, find period of the sinusoidal function. So the period over here is when does this repeat? So if I check the maximums, I know it repeats at 4. So the period in this case is 4 units. You see that? So that is the period. So this becomes the period for the cosine function or for the sines. Both are same, right? So sine also is from here to there, which is 4 units. When we say period is 4, which we've just found, we have all explained how the sine function graph can be obtained from the cosine function. So we can write this as cos of x is equal to sine of, well, we should take care of the period first. So it is not necessarily x. Um, Let me just now give you that k is equal to, in this particular case, if you want to write the equation in degrees, in that case it will be 360 degrees divided by the period, which is 4, correct? So that gives us the value of k as 90 degrees. You get the idea, right? So k is 90. And therefore, the cos function can be written as cos of, since k is 90, 90x. You see that? That becomes the value. And as far as the sine function is concerned, sine function will be written as sine of 90, and that is also 90x, sine of 90x. That is also correct. That is for the green graph, right? So this is the sine of 90x, correct? And the red graph is cos of 90x. These are two different graphs. Perfect. But in case you want to write cosine function as a sine function, then you could write that the first graph, which is the red graph, we could write this as a sine function also, right? Since as far as sine is concerned, this red graph will be right there, right? Sine starts here. So it will be written as sine of 90x, 90 x plus quarter of the cycle, and dividing this by quarter we get 1, right? So 1. So that becomes the equivalent function. This is equal to cos of 90x. Does make sense? So that is the equation of the graph, which is red in color. Okay, fine. Now let's move on. We'll actually look into these details later. Where we are going to explain what I'm talking about right here. Anyway, let us now read the characteristics from the transformed function. Since we have already done transformation in the earlier videos, which were based on sine function, I'm taking liberty to move ahead. Example 1 here is based on characteristics from the equation y equals to a cos k x minus p plus q. For each of the following equation, find the amplitude A, period P, phase shift lowercase p, which is also horizontal translation, and the principal axis Q, which we also call midline. So these are the 4 functions given to us. Make a table as shown here with amplitude, period, phase shift, and the horizontal vertical translation, the axis. Write down the equations and write the values. Well, most of the values can be directly read. Sometimes we may have to calculate. So for the very first one, cos of x minus 10, the amplitude is 1, the period is 360, phase shift is 10 units to the right. Sometimes you may write this as plus 10, and there is no vertical translation. In the second graph, there is an amplitude of 2, right? And 3. This number 3, which is the k value, gives us the period by dividing 360 by 3. So we have period of 120 degrees. There is no phase shift in this case, but there is a vertical translation, 1 unit down, written as minus 1. Now the next one, is, let me just push this a bit upwards, y equals to half. So the amplitude is half. It has been vertically compressed by a factor of 2. Horizontally, it has been compressed by a factor of 3, and therefore the period has been reduced to 120 degrees, 360 divided by 3. Phase shift is 10 units towards the left. We will write it as minus 10 and 5. It is a translation, vertical translation, by 5 units up. The next equation is cos of 2x plus 30. Now, whenever you're given an equation in this form, it is important to factor 2. Once you factor, we get the right value of the phase shift, which is 15, not 30. So that you will now notice that amplitude is 1, period is 360 divided by 2, which we factored, and phase shift is minus 15, means 15 degrees to the left, and it moves 4 units down. So that becomes the parameters from the given equation. Now let us also try to find the equation from the given graph, right? So the question here is, for each of the following graph, find the amplitude, period, phase shift, principal axis, and then write the equation of the form y equals to a cos k x minus p plus q. So let's try to understand how do we write the cosine function from the given graph. So the idea is to start with maximum and minimum value. So the maximum value in the first graph is at 2 and the minimum is at 0. So note these two values, maximum value and the minimum value. From the maximum and minimum value, you can find the axis and the amplitude, right? So first thing first, we'll find the axis first. So axis is q, which is the average value, right? So this is the average value which we're trying to figure out. It is maximum plus minimum divided by 2. We are writing capital M for maximum and lowercase m for minimum. So 2 plus 0 divided by 2 is 1. So the axis is at, you can say y equals to 1. Now amplitude is the difference between maximum minimum divided by 2, which is 2 here. So that is the amplitude. This distance here is the amplitude, right? So that is the amplitude A. Now let's find the phase shift. To find the phase shift, what do? We look into the position of first maximum. So in this case, where is the first maximum? That is what we're looking into. Now, clearly, the first maximum is at, let me use a different color, is at this point, correct? Now, this point here is 225. 45 to the right of 180. Do you see that? So this happens to be at 225, and that becomes the phase shift. So position of first maximum gives you the phase shift for a cosine function. Now what is the period? Now in this particular case, we can very easily read the maximum and the minimum. The two values are at 225 and 585. 45 more than 540. And their difference will give us the period. So this is period, and this is only half, so we multiply it by 2 to get the period. To find the value of k, 360 divided by the period gives us the value of k as half. Now we have all the parameters. Vertical stretched by a factor of 2, which is the amplitude. Horizontally stretched by a factor of 2 gives you half as k. Phase shift by 225 and 1 up. Translation vertical. Follow the same method and write down the equation for the next graph. So you have to write the cosine function in this particular form for the next graph. Well, the process is same. Look for the maximum and the minimum values. In this case, maximum minimum values are 1 and minus 3. So those are the values of capital M and small m. They will give you the average value, add them, divide by 2 as minus 1, and the amplitude as difference divided by 2. Amplitude is always positive, okay? You get 2. Phase shift. Now for the phase shift, we are looking for the first maximum, and we see that it is 2 units towards the right, and therefore the phase shift is 2. Period. In this case, we can read that half of the period is 2, so 2 times 2 is 4. That becomes the period. Since we know from minimum to maximum, it is half the cycle. Once we know the period, we can find the value of k. I've written this in radians. K will be 2 pi by period p, right? So k equals to 2 pi divided by period p. P is for us 4. So 2 pi by 4 gives us pi by 2. And using all these values, we get our answer that the equation of this graph is y equals to 2 cos of pi by 2 x minus 2 minus 1. Here is a question related to domain range of a cycle, right? So, as you know, domain is all real numbers. However, when you're talking about one cycle, normally it is 0 to 360 degrees. For transform function, we'll have a restricted domain. Now, interval for each cycle will be p, where p is the period. This interval will horizontally shift lowercase p units, resulting in the domain of the cycle, right? Therefore, the domain is all real numbers from the phase shift p minus of that, right, to the phase shift plus the period, correct? That is what it is. So in short, we could also write this as the value of phase shift to period plus phase shift. Now, as far as the range is concerned, it really depends on the axis and the amplitude. And therefore, the range will be from the axis minus amplitude, amplitude is always positive, to axis plus amplitude. That's it. That's how you get the range. We have 4 examples here. I'd like you to pause the video, write down their domain and range. Perfect. And then you can match the answers from this particular solution. Clear? Now, it is very important, again, I'm sending a reminder to you, that in the last example, where we have 2x minus 30, it is important to factor 2 to get the right values. So let me discuss last one here. As far as the domain is concerned, we have this function 3 cos of, we'll have to factor 2, right? So we'll factor 2, we get x minus 15, correct? Plus 1, correct? That becomes your equation. Now that clearly indicates that there is a phase shift of 15 degrees to the right? So we have a 15 degrees phase shift here. Since this is minus, it is positive. And there's a time period of let me make a change here because both are similar. So that gives you plus 15, and this answer is not correct. So 180 plus 15. So the domain will be from 15. I'm writing domain first. Well, let's write on the period. Period for this function is, because there are 2 waves in 360, each will have a period of 180 degrees. So the domain is from, there's a phase shift of 15 degrees, so it is from 15 to 15 plus 180. You get the idea, right? So that is the domain. So it is from 15 to 591, 195. Similarly, before this, the domain should have been from plus 30 because the graph moved 30 units right, correct? And it is 180 plus 30. So this should have been, let's rewrite them. So this is from 30 to 180 plus 30, which is 210. And here it is from 15 to 15 plus 180 means 195 degrees, correct? So that becomes the domain. Perfect. The graph moves right. by 15 degrees in the second case. As far as the range is concerned, we go from axis, which is at 1, to the lower value, which is minus 3. So 1 minus 3, so basically it goes from 1 minus 3 to 1 plus 3. 1 minus 3 is minus 2, and 1 plus 3 is 4, and that is how you get it. So basically, you have to add the amplitude to the axis to get the maximum and subtract amplitude from the axis to get the minimum. Let's move forward and find the equation from transformation. The equation here is, write an equation in the form of y equals to a cos x plus q that models each graph with the following properties. There are 4 questions here. The graph of y cos x, y equals to cos x, is stretched vertically by a factor of 3 and translated 2 units up. You need to write the equation for this description. B. The graph of y equals to cos x is reflected on the x-axis and horizontally compressed by a factor of 0.5. C. The graph of y equals to cos x is reflected on the x-axis, has a period of 90 degrees with range y belongs to real number and y is between 1 and 7, both included. D. The cycle of a sinusoidal function has domain between 0 to 180 degrees and range between minus 2 and 4. So I'd like you to pause these questions and then look into my suggestions. Now here are the solutions to each one of them. We'll begin with A, which says the graph of the parent function y equals to a cos x is stretched by a factor of 3. So when we say stretched by a factor of 3, it means the amplitude is 3 now. Second is translated 2 units up, that means q is 2. Substituting this in our general equation, which is y equals to a cos of k x minus p plus q, right? So we can write a and q values and write down a function which is y equals to 3x plus 2. In part B, we are looking for reflection on the x-axis, means a value will be negative, right? Now since there is no stretch, it is negative 1. Horizontally compressed by a factor of 0.5 means k is 2. So substituting this value of k and minus 1 for a, we get y equals to minus cos 2x. So that fits the description, correct? C. The graph of y equals to cos x is reflected on the x-axis, right? So if it is reflected on the x-axis, we do get negative. Hence, the period has a period of 90 degrees. Now we know the value of period, so k value will be 360 divided by 90, and in this case, k will be 4. Range is from 1 to 7. So we are given the absolute minimum and absolute maximum. So using these values, 7 and 1, we can find the amplitude, and also the average value gives us the shift. So you have to do this work to get the values 3 and 4 respectively, and that gives you the function y equals to minus 3 cos 4x plus 4. Clear? The last example here is that the cycle of the cosine function has a domain from 0 to 180. That means the period is 180 degrees, correct? And 0 means there is no phase shift. And therefore, using this information, we can find that the k value is 360 divided by 180, which is 2. Now we are also given the range. Range means maximum and minimum value. When we subtract them and divide by 2, we get amplitude. Add them, divide by 2, we get axis, which is 1 in this case, amplitude 3. There you go. So we are seeing how the transformation of these functions work. How do we write the equation from the graph? And if a given description is there, then we could also write the equation. Now, let's look into these transformations one by one. We'll begin with the vertical stretch, which normally is because of the factor a. So y equals to a cos x. If a is greater than 1, it's a vertical stretch. If a is between 0 and 1, It is a vertical compression by a factor of a. If the value of a is less than 0, that means it is negative. In that case, what? See, cos function is even function, right? So let me write down here. We have cos of minus x, that is one thing. No, we're talking about the amplitude at present. So in this case, if a is negative, it gets reflected on the x-axis. That's so simple, right? So that is reflected on the x-axis. Now, if a is greater, then there will be a stretch, then 1. If a is between 0 and 1 in magnitude, then there will be a compression. Now, these examples illustrate. So if we are talking about 2 cos x, then the graph will be vertically stretched as shown here. But if we are talking about half cos x, in that case, the graph will be compressed as shown by the orange line here, as compared to the normal graph shown in green. But if we have negative value, in that case, instead of starting with the maximum, the graph starts with the minimum. So there is a reflection. Plus, it is not starting at -1, it is starting at -3, since in this particular case, well, on the graph I've shown -2. So let me just change this. The graph is showing -2, right? So I'm taking this to be -2. Okay. So we have doubled it. So that is the graph with negative starting point of -2. So this is minus of cos 2x. So y equals to -2 cos x. So that is the graph which we are showing in blue. Okay, clear. Now we'll talk about vertical translation. Now vertical translation is because of q. If q is positive, we get a function which is translated up. If q is negative, we get a function which is translated down. So in this particular example, we have shown you 3 graphs where the value of q is 0, -3, and 2. Now, I'll also encourage you to look into these key points which will be there on the parent function. And these key points, which basically are the 5 points 1, 0, -1, 0, and 1. So I'd like you to write down the corresponding points on the image of the given transformed functions, right? That's kind of important. Another important question here is, list the characteristics which do not change because of the vertical translation. So these are the 3 parameters which do not change: period, amplitude, and domain. Perfect. So that is very important to see while you're answering different questions, because in a test, many different questions can be on the same concept. Now here is another one where we'll talk about the horizontal stretch. Horizontal stretch is given by the parameter k. If k is greater than 1, then we get horizontal compression by a factor of 1 over k. But if k is between 0 and 1, we get horizontal stretch by a factor of 1 over k. If k value is negative, then what? Cos of minus x is equals to cos of x. So since it is an even function, if k is less than 0, it really doesn't matter. Remains same. Unchanged. Is that clear to you? Since cos of minus kx is equals to plus kx. So here we have 3 examples. We have taken value of k as 1, 2, and half. 1 is by default the cos function with a period of 360 shown in red in this particular case, right? So the graph in red is shown for cos of x. The graph which is in green is the graph of cos of 2x. And the blue graph is the graph for cos of half x. Clear? So these 3 graphs are shown on the same axis. You can now compare that the difference in them is mainly because of the period. Correct? So the period is related as period will be equals to 360 divided by k, right? That is how the period is related. I'd like you to go through this, read all the text, and then once again, we have a similar question. Characteristics that do not change for this transformation are what? Correct? These are very important things to understand. These are amplitude, maximum, minimum, and equation of axis, which will not change by change in any horizontal parameter like phase shift. Now, let's look into phase shift. How do we incorporate phase shift in a graph? We'll consider the function cos of x minus p. It really means that the cosine function has moved or translated horizontally by p units, correct? So in a transformed function, g of x equals to a cos k plus q, the parameter p affects the horizontal translation of a shift. If p is greater than 0, then it is translated horizontally p units right. If p is less than 0, then the translation is p units left. Right. So that is how it is. The graph of cos x in this case has been translated left to give you the graph of cos x plus 30 while shown on this figure. That is the example 6. We have to sketch and explain the transformation of y equals to cos of x plus 30. So y equals to cos of x plus 30 means that the graph of cos x is translated horizontally by 30 degrees to the left to obtain the transformed function y equals to cos of x minus 30. Now that brings us to the end of this particular video with two test examples. I'd like you to look at these examples, pause the video, answer, and then into my solution. The very first one here is to write equation that represents the cosine function. So that is the cosine function given to you. You can now pause the video and write its equation. I will also prefer you to write two different equations. Now let me explain you how do we write equation from the graph. Steps followed are, as we did earlier also, we'll actually look into the maximum and minimum values. The maximum value is 3 here and the minimum is minus 1. So these values, maximum of 3, minimum of minus 1, will actually, plus 1, will actually give us the amplitude and the axis. Difference divided by 2 gives the amplitude of 1. Sum divided by 2 gives axis equals to 2. So you can actually draw the axis as shown here, or the midline as we say. Now we can find the period from maximum and minimum value positions, right? So in this case, we can say that this minimum is at minus 30, right? This is at minus 30, and this maximum is at 60. Their difference will give us the period times 2. I mean, this is half the way, right? So from minimum to maximum, we have half the cycle. So this is half cycle. Sorry. So we'll double this up. So in this case, it will be 60 minus of minus 30 times 2, right, to get the period. So which gives us 180 degrees, right? So it is 180 degrees, which is the period for us. That gives us the value of k. 360 divided by p, the value is 2. So we do get all the parameters except for one, which we'll discuss now. So we got the amplitude as in this case 1. We got the value of q as 2. We got the value of period, which gets converted to the value of k as equal to 2. So we got these values. Now we have to look into the phase shift, correct? To find the phase shift, we can either consider the minimum point or the maximum point. If you consider the maximum point, the graph has been translated so much, which is 60 units right, correct? So it is 60 right. So that gives you the equation y equals to 2 cos x 2 times x minus 60 plus 2. That means the cos x function has moved 60 units to the right. So that gives you the first equation, right? Another equation we could look into the minimum. Minimum is towards the left at minus 30. So x plus 30 will be the right thing. However, it starts with the minimum. Therefore, we'll write y equals to minus 2 cos of 2 cos x plus 30 plus 2. Correct? Since it starts with negative, it is as if it has been flipped on the x-axis, right? That is how we get this equation. So I hope the concept is clear. Now, here is the last question for you. Consider the function g of x equals to minus 5 cos of half x plus 30 minus 1. Describe the characteristics of one cycle. One cycle, okay? So underline this word of a cycle. Correct. Write domain and range of one cycle. Describe the transformation of the function g of x. Sketch the graph showing all transformations from the parent function. So I'd like you to take up this question, right? Answer and then look into my suggestions. So here we can write down the axis is minus 1. That is the axis, correct? Then we have the amplitude, which is 5. Amplitude is always positive. And then since we have the axis and the amplitude, we can find what is the maximum value. Maximum value is axis plus amplitude. And the minimum value is axis minus amplitude. So when you add them up, 5 and minus 1, you get 4, which is the maximum value. And their difference. Minus 1 minus 5 gives you minus 6 as the minimum value. Period. Now, in this graph, period is related with the k value of half. So the period has to be 720. 360 times 2. Phase shift is minus 30. That means 30 units left. And therefore, the equation will be as shown here. This is the domain. Equation will show later. So the domain is from minus 30 to 720 minus 30, right? Since the period is 720. So that is how you get this value 690. And the range is axis minus amplitude. That means minus 1 minus 5, which is minus 6, and minus 1 plus 5, which is plus 4. So you can write the domain of this function as from minus 30 to 330, not 330, 690. Correct? 690. And the range is from minus 6 to 4. As far as transformations are concerned, always described from left to right. So minus 5 means reflection on the x-axis, vertical stretch by a factor of 5, horizontally stretched by a factor of 2, horizontal transformation 30 degrees left, and vertical translation 1 unit down. So that is all, right? So if you want to sketch this, you can begin with that axis, which is y equals to minus 1, correct? And the maximum value in this particular case you found as 4. Let's say this is your maximum value. I'm just drawing. Minimum value is 6, correct? So what I've drawn here is this value is 4. This is the axis, which is at the value, average value of minus 1. And this is minus 6, correct? So cosine function is within this period. It definitely starts with the maximum, and then let me just say one cycle we're doing starts with the maximum, then it goes to the axis and then comes to the minimum, goes back to the axis and maximum. So one cycle could be drawn like this. As far as the points are concerned on this cycle, if I sketch the y-axis and x-axis, which will be, let us say, something like this. Okay, and since it has moved 30 units to the left, I'm just doing, this is a rough diagram. Correct? So that is how we are going to sketch it. Perfect. Well, this point here is at minus 30 and the maximum is at 690. Is that clear to you? Correct? So all the values, uh, we have subtracted 30 since it has moved 30 units left. So that is how we'll have the graph of the function. Is that clear to you? So I hope that makes sense. This is a rough sketch which is fairly accurate. I'd like you to pause this video. Look at this once again. Try to sketch an accurate diagram, right? Hope it makes sense. So with this, we come to an end of this particular video. I think you have learned all these parameters related to the transform function of cosine x, and we have also seen how do we describe a transformation, how do we write an equation from the given transformation, how do we write equation from the given graph, and how do we sketch a graph. Perfect. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. And if you want to learn from me, you can always send an email on the given address and also check our website for some new videos. Thanks for your time and all the best.